10 space phenomena scientists still can't explain. The universe is not just a backdrop for our existence. It is a stage filled with mysteries that continue to defy the grasp of human understanding. For millennia, we have looked to the heavens for answers, and with each discovery, we believed we were closer to unraveling the truth of creation itself. Yet every breakthrough seems to open the door to a deeper enigma, a reminder that the cosmos is not only vast but also elusive, guarding secrets that resist even the sharpest of intellects. As our telescopes reach further into the dark, as our instruments become more sensitive to the whispers of distant stars, we are confronted not with certainty, but with a growing awareness of how little we truly know. It is here, in this space between knowledge and mystery, that the human spirit is tested, where curiosity becomes both a guide and a torment, pulling us toward the unknown with a force as undeniable as gravity itself. The night sky appears calm and unchanging to the naked eye, but hidden beyond that quiet expanse are forces so powerful and so strange that they challenge the very foundations of science. There are stars that flicker with patterns too precise to be random, as if broadcasting signals across the void. There are galaxies spinning faster than our laws of physics should allow, as though dragged by some invisible hand. There are bursts of radio waves from billions of light years away, so brief yet so intense that for a moment they release more energy than entire suns. We detect these anomalies, we measure them, we catalog them, but explanation remains out of reach. The greatest minds of our age, astrophysicists, mathematicians, cosmologists, can only construct theories that crumble under the weight of new observations. This is not a failure of science, but its essence. For every solved equation, the universe offers us a new paradox. For every star mapped, another mystery takes shape in the shadows. The more we learn, the clearer it becomes that the cosmos is not a machine running on predictable gears, but a living riddle, always one step ahead of our comprehension. And it is this tension, this dance between knowledge and ignorance, that makes the quest for understanding so urgent. Because if these mysteries remain unsolved, they are not just curiosities, they are reminders that we do not yet know the true rules that govern existence itself. Think for a moment about what this means. If galaxies move as though influenced by an unseen force, then perhaps there are elements of reality we have not yet detected. If signals pulse across space with uncanny precision, perhaps they are more than just natural phenomena. If matter behaves in ways that contradict our physics, then perhaps our physics is incomplete. Each phenomenon whispers a possibility that could rewrite not only the textbooks, but the very story we tell ourselves about who we are, where we come from, and where we are going. This journey into the unknown is not merely scientific, it is existential. It touches the deepest parts of the human psyche, stirring both awe and fear. Because hidden within these mysteries is a confrontation with our fragility. We like to think of Earth as solid, as home, as the center of meaning, but in the vast expanse of the universe, we are a speck surrounded by forces that could unravel our certainties in an instant. And yet, it is precisely this fragility that gives our search for understanding its urgency. Every unanswered question is a call to look deeper, to push further, to refuse complacency. Tonight, we are going to step into that frontier. We will explore 10 of the most perplexing space phenomena that continue to baffle scientists, each one a doorway into the vast unknown. These are not distant curiosities to be observed from afar. They are active mysteries, unfolding in real time, shaping our understanding of reality even as they defy explanation. They are clues, perhaps, to truths that remain hidden, pieces of a puzzle so immense that we can barely comprehend its edges. Some may one day be explained by science. Others may remain enigmas for centuries, fueling wonder and speculation for generations to come. So stay with me. Do not turn away from the discomfort of the unknown, because within it lies the greatest adventure of all. Tonight, as we journey together across the cosmos, we will stand at the edge of understanding, peering into mysteries so profound that they may forever change the way you see the night sky. What awaits us is not just knowledge, but perspective. And perhaps by the time we reach the final mystery, you will realize that the most extraordinary discovery is not what lies out there, but what these enigmas reveal about ourselves. Before we begin unraveling these mysteries, ask yourself this: Do you want to be just a passerby in the universe or a seeker of its hidden truths? If you choose the second, then stay with us until the end, subscribe, and share this journey.
Because here, every question is more than curiosity. It's a step into the unknown. They are among the strangest and most fleeting mysteries ever recorded in the heavens. Sudden flashes of radio energy, lasting less than the blink of an eye, yet unleashing more power than our sun produces in days. These are the fast radio bursts, or FRBs, discovered only 2 decades ago and already reshaping the boundaries of astrophysics.
Imagine for a moment the silence of space broken by a whisper from billions of light years away, a signal so brief you might think it was a glitch, so powerful it challenges the limits of what we believe possible. For years, scientists have attempted to decode these signals, to pin them down to familiar causes, but each attempt seems to lead only to new questions, as if the universe itself were toying with our curiosity, offering just enough to intrigue, never enough to explain. The first FRB was detected in 2007, buried in old data, like a cosmic secret overlooked until human technology was finally sharp enough to notice it. Since then, telescopes around the world have captured hundreds more, yet their origins remain uncertain. Some appear as isolated events, erupting once before fading forever into silence, leaving no trace, no pattern, no explanation. Others repeat, not randomly, but in cycles that hint at some deeper rhythm, like a heartbeat in the fabric of the cosmos. One repeating FRB even follows a schedule, on for a time, then silent, then active again, as if obeying rules we cannot yet decipher. Are we witnessing natural astrophysical events, or is there something more intentional, something designed, hidden behind these bursts? Explanations abound, each more extraordinary than the last. Some point to collapsing neutron stars, remnants of once massive suns squeezed into objects so dense that a teaspoon of their matter outweighs mountains. Others suggest magnetars, stars with magnetic fields billions of times stronger than anything we can replicate on Earth, capable of twisting space itself into knots of unimaginable energy. There are theories involving black holes, with FRBs being the echoes of matter consumed and spat out at the edge of event horizons. Others stretch further still, proposing cosmic strings, hypothetical relics of the early universe, or exotic physics beyond anything we currently understand. And then, lingering in the shadows of scientific caution, there is the possibility that some of these bursts are not natural at all, but signals from intelligence beyond Earth. If that were true, then each flash could be a beacon, or perhaps the byproduct of technologies so advanced that they manipulate forces of the universe we can barely measure, let alone comprehend. What unsettles astronomers most is not just the power of FRBs, but their unpredictability. They arrive without warning, without pattern, and they vanish almost as soon as they appear. Capturing one requires immense patience and a network of telescopes scanning vast swaths of sky, waiting for an instant that may never come. Even with all our technology, we are like fishermen casting nets into a cosmic ocean, catching glimpses of creatures so rare and fleeting that we cannot know what they truly are. And yet, with every detection, our fascination grows, because each FRB represents a tear in the veil of normality, a moment when the universe reminds us that it is still full of secrets. There is an existential dimension to these mysteries. If FRBs are natural, then they could reveal aspects of the cosmos that we have not yet imagined. Forces, structures, or processes that expand our understanding of physics and of reality itself. If they are artificial, the implications are staggering. Confirmation that intelligence exists elsewhere, that other beings have found ways to harness the raw power of the universe, perhaps for communication, perhaps for purposes we cannot even guess. Either way, the bursts carry a message, even if it is not in words. The universe is stranger and more dynamic than we dared to believe. But perhaps the true power of FRBs lies not in what they are, but in what they symbolize. They are reminders of how much we still do not know, of how incomplete our knowledge truly is. They humble us, forcing us to admit that our equations and theories, no matter how elegant, are provisional, temporary, fragile in the face of new data. And at the same time, they inspire us, igniting the fire of curiosity that has always driven humanity forward. Each burst is a challenge, a call to look deeper, to question more boldly, to push the boundaries of science and imagination alike. They whisper to us from across the cosmos, not with answers, but with questions that demand we continue the search. So the enigma remains. Are fast radio bursts the cries of dying stars, the fingerprints of new physics, or the deliberate pulses of civilizations lost in the darkness of space? No one knows for certain. But what we do know is this. Each time we catch one, we are reminded that the universe is alive with mystery, and that we are still at the very beginning of understanding the forces that shape it. There are mysteries in the cosmos that seem to challenge not only our understanding of physics, but the very structure of reality itself. Among them is one of the strangest discoveries of modern astronomy, something scientists have come to call the dark flow. Imagine thousands of galaxies, each one a massive island of billions of stars, all drifting through the universe. By all logic, these galaxies should be moving in random directions, pulled gently by the local gravity of nearby structures, or stretched outward by the expansion of the cosmos. But when astronomers looked closely at the data, they found something that shook their assumptions. Vast clusters of galaxies, separated by unimaginable distances, all appeared to be moving together, as though being pulled toward a single unseen point. The scale is staggering. We are not talking about the motion of a few galaxies, but about whole swaths of the universe, enormous regions spanning hundreds of millions of light years, all flowing in the same direction with a velocity that cannot be explained by anything inside our observable universe. The discovery came in 2008, when researchers using NASA's Wilkinson Microwave Anisotropy probe examined tiny fluctuations in the cosmic microwave background, the faint afterglow of the Big Bang. By tracking how galaxy clusters distorted this ancient radiation, scientists noticed a peculiar pattern. Instead of moving randomly, the clusters showed a coherent motion, all drifting toward a region beyond the edge of what we can see. This became known as the dark flow, a term as unsettling as the phenomenon itself, because it implies a hidden force acting on scales larger than the visible universe. The very name suggests a current in the cosmic ocean, pulling galaxies like driftwood toward an invisible abyss. Explanations have been proposed, but none are fully satisfying. Some suggest that the flow is caused by gravitational influences from structures that exist outside the observable universe, regions so far away that their light has not yet had time to reach us since the Big Bang. If true, then what we see as the universe is only a small patch of a far larger reality, and the dark flow is the faint tug of something enormous beyond our cosmic horizon. Others speculate that the flow could be evidence of a multiverse, that our universe is not isolated, but part of a greater expanse of realities, with neighboring universes exerting their influence across the boundaries. Still others hint that the phenomenon could be telling us that our models of cosmic expansion, our very understanding of gravity and space-time, are incomplete. What makes the dark flow so haunting is not just its scale, but its direction. The galaxies appear to be moving toward a region of the sky near the constellations Centaurus and Hydra, but beyond that we cannot see what lies ahead. It is a blank canvas, a void from which no light has yet reached us, and yet it exerts a pull strong enough to bend the motion of entire galactic superclusters. It is as though the universe itself is pointing beyond its own visible edge, inviting us to consider that what we can observe is only a fraction of what truly exists. The thought is both exhilarating and terrifying, because it means we may never be able to confirm what lies in that direction, yet we cannot deny the evidence of its influence. The implications are profound. If the dark flow is real, it changes everything we think we know about cosmology. It suggests that the universe is not homogeneous and isotropic on the largest scales, as we once believed, but influenced by structures we cannot see or measure directly. It could mean that our observable universe is just a bubble within a much larger cosmic structure, one with forces and dimensions beyond our reach. And if the multiverse hypothesis is correct, then the dark flow may be the first tangible evidence that other universes not only exist, but interact with ours in subtle gravitational ways. Yet despite its significance, the dark flow remains controversial. Some scientists argue that the data could be misinterpreted, that what we see as coherent motion may be an artifact of measurement or an illusion caused by statistical noise. Others insist that the pattern is too persistent, too consistent to be dismissed as coincidence. The debate itself is a reflection of how science operates at the edge of the unknown, where evidence is scarce and conclusions are provisional. It is a reminder that our models, no matter how elegant, are only as strong as the data they are built upon, and the universe has a way of humbling us whenever we believe we are close to understanding it. But beyond the scientific debate, the dark flow captures something primal in the human imagination. The idea that the universe itself is being pulled toward something unseen awakens old myths of hidden realms, of forces beyond the horizon. It echoes our deepest fears and hopes, that there is more out there than we can ever know, that reality stretches further than our eyes or instruments can reach. Perhaps the dark flow is not only a scientific puzzle, but also a metaphor for our condition as a species, always moving, always drawn toward the unknown, compelled by forces we cannot fully explain. For now, the dark flow remains unresolved, a silent current guiding galaxies across the cosmos, its source hidden in darkness. Whether it is the shadow of another universe, the pull of unseen structures, or the signal that our understanding of physics is incomplete, it is a phenomenon that demands our attention. It reminds us that no matter how far we extend our reach, there will always be mysteries that slip beyond the edges of our perception, calling us to wonder what lies just out of sight. For decades, dark matter has been one of the most haunting enigmas in modern science. We cannot see it, touch it, or measure it directly, yet its fingerprints appear everywhere in the cosmos. The way galaxies spin, the way clusters of galaxies move, the bending of light around massive structures, none of these make sense unless there is something invisible adding weight to the universe. Something that does not emit or absorb light, but exerts a gravitational pull strong enough to hold entire galaxies together. According to our models, dark matter makes up about 85% of the matter in the cosmos. Without it, galaxies should have flown apart long ago, scattering their stars into empty space. And yet, despite its dominance, dark matter remains elusive. We cannot explain what it is, we cannot find the particle that composes it, and worst of all, in some places where we expect it, it appears to vanish completely. The most startling evidence came from a galaxy known as NGC 1052 DF2. Discovered in 2018, this faint, ghost-like galaxy stunned astronomers because its stars and clusters seemed to move in ways that could be explained without any dark matter at all. It was as if the galaxy had formed and evolved without the very substance that is supposed to be the backbone of all galactic structures. Later, another galaxy with similar properties, DF4, was found. Together, they seem to challenge one of the most fundamental assumptions of cosmology, that dark matter is universal, omnipresent, and indispensable. If some galaxies can exist without it, then our entire understanding of how the universe forms may be incomplete. The mystery deepens when we compare galaxies side by side. Some dwarf galaxies orbiting the Milky Way seem to be dominated almost entirely by dark matter, with far more of it than visible stars. Others, like DF2 and DF4, seem to have none at all. How can both extremes exist in the same universe? If dark matter is a particle, how could it be absent in one place and overwhelming in another? Some scientists argue that tidal interactions, gravitational tugging from nearby larger galaxies, may strip certain systems of their dark matter. Others suggest that dark matter may not exist as we imagine, that what we call its effects are simply signs that our laws of gravity are incomplete at cosmic scales. Modified theories of gravity, though controversial, propose that perhaps we do not need dark matter at all. Perhaps the rules themselves are different. The search for dark matter has led to massive experiments deep underground and in space, all designed to detect its elusive particles. We have built detectors buried beneath mountains, shielded from cosmic rays, waiting for the faintest sign of interaction with a particle that may never reveal itself. We have scanned the skies for signals of annihilation or decay that might betray its presence. But so far, nothing definitive has been found. The silence is deafening. And now, galaxies like DF2 and DF4 mock us further, suggesting that dark matter may not be the universal glue we once believed, but something far stranger, something unevenly distributed or not fundamental at all. This vanishing act is more than just a curiosity. If dark matter is not what we think, then the very framework of cosmology, the Big Bang model, the evolution of galaxies, the growth of cosmic structures, must be revisited. Our theories rely on dark matter as an invisible scaffolding upon which the universe is built. To remove it, or even to admit exceptions, is to risk dismantling the architecture of modern astrophysics. And yet, science thrives on such risks. Every anomaly, every galaxy that refuses to play by the rules is a clue that we are on the edge of a deeper understanding. But there is another, more unsettling possibility. What if dark matter is not a substance at all, but a shadow of something more profound, an effect of dimensions we cannot see, or the residue of interactions between universes? Some theorists whisper of hidden sectors, mirror matter, or even the influence of forces outside our observable reality. If galaxies like DF2 are real, then perhaps they are windows into these hidden domains, cracks in the veil where the rules briefly shift, revealing that our universe is far less uniform than we imagine. The vanishing dark matter problem confronts us with two equally staggering possibilities. Either dark matter exists and behaves in ways we do not understand, or it does not exist at all, and we are chasing a phantom. Both options force us to rethink not only our models of the cosmos, but our place within it. If the universe can build galaxies without dark matter, then perhaps the rules of creation are broader and more flexible than we ever dreamed. And if dark matter itself proves to be an illusion, then one of the greatest quests in modern science may transform overnight, revealing not an answer, but a whole new set of questions. For now, we are left staring into the dark, caught between evidence and absence, between galaxies that obey and galaxies that rebel. The case of the vanishing dark matter is not just a puzzle, it is a challenge to humility, a reminder that the cosmos will not bend to our expectations, that it will always keep some of its truths hidden, waiting for us to stumble upon them at the edge of understanding. Long before humans built telescopes to scan the skies, the universe left behind a silent record of its birth. It is called the cosmic microwave background, the faint afterglow of the Big Bang itself, still echoing across the cosmos more than 13 billion years later. To our instruments, it appears as a soft haze of radiation filling every corner of space, almost perfectly uniform, as though the early universe had been smooth and balanced in every direction. Almost, but not quite. Hidden in that faint afterglow are tiny fluctuations, subtle variations in temperature that represent the seeds of all future structure. Galaxies, stars, and planets all trace their origins back to these delicate ripples. But among them, there is one anomaly that defies explanation, one region so strange that it has become a riddle in the very blueprint of the cosmos. Astronomers call it the cold spot. The cold spot is exactly what its name suggests, a region of the cosmic microwave background that is significantly colder than expected, stretching across a patch of sky larger than 30 times the diameter of the full moon. In a universe that should be statistically random with small fluctuations here and there, this anomaly is simply too extreme to fit the models. When first detected in 2004 by the Wilkinson Microwave Anisotropy Probe, it was met with skepticism, dismissed as a possible error or artifact of measurement. But years later, the Planck satellite confirmed its existence with even greater precision. The cold spot was real, and it was unlike anything else in the observable universe. What could cause such an anomaly? The first explanation offered was that it might be the result of a vast void in space, a supervoid, hundreds of millions of light-years wide, containing far fewer galaxies than usual. Such a void would distort the path of light traveling through it, making the region appear colder than its surroundings. And indeed, astronomers did find evidence of a large underdense region in the direction of the cold spot. But the scale of the void, while impressive, is not nearly enough to account for the anomaly's size and intensity. The numbers simply do not add up. The cold spot is too cold, too vast, and too coherent to be explained by conventional structures. This has led to more exotic theories, each more unsettling than the last. Some suggest that the cold spot might be the imprint of a collision between universes. If our universe is only one bubble in a multiverse, then perhaps in its infancy, it brushed against another bubble universe, leaving behind a scar in the fabric of the cosmic microwave background. If true, then the cold spot would be the first tangible evidence that our universe is not alone, that beyond the veil of the observable horizon, other realities exist. each with its own laws of physics, each with its own story of creation. Others argue that the cold spot may point to fundamental flaws in the standard model of cosmology itself, hinting that the universe is not as uniform or as predictable as we thought. There are also those who consider it a statistical fluke, a rare coincidence that just happens to exist in our observable patch of the cosmos. After all, improbable things can and do happen in a universe this vast. But the problem with that explanation is its unsatisfying simplicity. The cold spot is too conspicuous, too persistent across multiple instruments and observations to be easily dismissed. In science, anomalies often signal the cracks in our assumptions, the places where the universe whispers that there is more to discover. To call it a fluke is to close the door on possibility. What makes the cold spot so captivating is not just its existence, but its implications. If it is a void, then it forces us to reconsider the distribution of matter on the largest scales, challenging the assumption that the universe is homogeneous. If it is evidence of a multiverse, then it changes everything, transforming our story from one of a single cosmos to one of infinite variations, each brushing against the other like waves on an endless ocean. If it is a flaw in our models, then it may point to a revolution in physics, a new way of understanding space, time, and the origins of all structure. And if it is simply a coincidence, then it is a reminder that even randomness can produce patterns that stir our imagination, that make us wonder whether meaning is written into the fabric of chance. But perhaps the greatest mystery of the cold spot is not what it tells us about the universe, but what it tells us about ourselves. That we are capable of noticing such subtle deviations in the faint afterglow of creation, that we can look across billions of light years and detect a temperature difference of mere millionths of a degree, is a testament to human curiosity. It shows that even when the universe hides its secrets in the faintest whispers, we strain to listen, and in doing so, we confront the possibility that the cosmos is far stranger than we dared to dream. For now, the cold spot remains unresolved, an icy fingerprint in the fabric of the early universe, as though something unknown pressed against our reality long ago and left behind a mark. Whether it is the sign of another universe, a cosmic void, or a flaw in our understanding, it is a reminder that the universe is not as smooth and simple as we once imagined. It is textured with anomalies, woven with riddles, shaped by forces that remain beyond our grasp. And perhaps, just beyond that cold shadow, lies the doorway to the next great revolution in our understanding of existence itself. In the depths of interstellar space, far from the warmth of any star, wander worlds that defy the very definition of what we thought a planet should be. They are called rogue planets, and unlike the familiar worlds that orbit suns, these dark nomads drift endlessly through the galaxy, alone, untethered, and silent. For centuries, the very idea of such planets seemed absurd. How could a planet exist without a parent star to anchor it, without the light and heat needed to sustain it? Yet modern astronomy has revealed that the galaxy may be teeming with them, perhaps more numerous than the stars themselves. And their existence raises profound questions about the nature of planets, the origins of life, and the hidden architecture of the universe. Rogue planets can form in two ways. Some are born in the cradles of stellar nurseries like any other world, but gravitational interactions with larger planets or nearby stars eventually fling them out of their orbits, casting them adrift into the void. Others may form in isolation, collapsing directly from clouds of gas and dust without ever igniting into stars. Either way, once set loose, they embark on solitary journeys through the galaxy, invisible against the blackness, detectable only through the faint gravitational lensing they cause as they pass in front of distant stars. The scale of this phenomenon is staggering. In 2021, astronomers studying microlensing events in the Milky Way suggested that rogue planets might number in the hundreds of billions, possibly outnumbering stars. Imagine that. A galaxy filled not only with suns and their families of planets, but with vast legions of dark worlds wandering aimlessly, each carrying its own history, its own geology, and perhaps its own secrets. In such a vision, the universe becomes not a gallery of bright star systems, but a labyrinth of hidden worlds drifting silently in the dark. But what would such a planet be like? Without a star, its surface would be shrouded in eternal night. Temperatures would plummet to unimaginable lows, freezing any exposed atmosphere or oceans. To us, such places sound utterly inhospitable. Yet the universe often defies our expectations. A rogue planet with a thick atmosphere could trap residual heat, creating a warm interior beneath a frozen shell. Others might harbor radioactive elements or geothermal activity capable of sustaining subsurface oceans. In such environments, cut off from starlight, life could still emerge, not as we know it, but as something adapted to chemical energy, thriving in the depths, hidden from our view. This possibility transforms rogue planets from cosmic curiosities into potential cradles of life. If even a fraction of them host conditions suitable for biology, the number of possible life-bearing worlds increases exponentially. Life, it seems, may not be confined to the warm embrace of stars, but could also flourish in the cold solitude of interstellar night. In that sense, rogue planets are not only wanderers, but also hidden laboratories, carrying the potential to rewrite our understanding of where and how life can exist. The implications reach further still. Some scientists speculate that rogue planets could serve as vessels of panspermia, carrying microbial life across the galaxy. If a rogue planet were once home to oceans and living organisms before being cast into space, some of that life might survive underground, shielded by ice or rock, preserved as it drifts between star systems. Over millions of years, such worlds could become cosmic seeds, spreading life from one corner of the galaxy to another. Perhaps even our own origins are tied to such a journey, with Earth seeded by material from a wandering world long ago. And then comes the unsettling question: what would it mean if we ever encountered one? A rogue planet drifting close enough to our solar system could profoundly alter its balance, tugging on the orbits of outer worlds, disturbing comets, even reshaping the long-term stability of Earth itself. While the chances are remote, the possibility serves as a reminder that the galaxy is not a static stage, but a restless arena where unseen forces move in silence. To detect such a visitor would be both a triumph of science and a chilling confrontation with the vulnerability of our place in the cosmos. Perhaps what makes rogue planets most fascinating is the way they redefine our imagination of the universe. They remind us that not all worlds are bound to stars, that not all life requires sunlight, and that the galaxy is not merely the glittering pattern of constellations we see from Earth, but an ocean filled with shadows drifting in between. For every star that dazzles our eyes, there may be countless unseen worlds, moving without witnesses, carrying stories we may never know. The existence of rogue planets asks us to rethink the word home. We associate it with the warmth of the sun, with light, with the cycles of day and night. But what if there are civilizations, hidden somewhere in the galaxy, whose ancestors arose not under a sunlit sky, but in the glow of geothermal fires beneath an endless night? Their myths, their concepts of life and survival, would be shaped by darkness, not by light. And if such beings exist, their perspective on the universe would be unimaginably different from ours. For now, rogue planets remain invisible wanderers, their presence betrayed only by fleeting distortions of starlight. They are the ghosts of the galaxy, countless in number, hidden in silence, each carrying the possibility of secrets that could change everything we think we know about life and the cosmos. In their quiet journeys, they remind us that the universe is far more vast, far more complex, and far more mysterious than even our boldest imaginations dare to grasp. There are mysteries in the universe that challenge not just our science, but our very capacity to imagine. Among them is something known as the dark flow, a cosmic enigma that suggests our universe might not be self-contained, but rather pulled by forces beyond what we can see. The term itself sounds like poetry, but it is grounded in a series of observations that defy conventional cosmology. When scientists studied the movement of galaxy clusters across the observable universe, they noticed something extraordinary. These massive structures seem to be drifting together, not randomly, but in the same direction, as if an unseen current were carrying them toward a destination we cannot see. It was as though space itself were flowing, like water drawn to an invisible drain beyond the edge of our cosmic horizon. To understand why this is so unsettling, we must recall what modern cosmology assumes. According to the Big Bang model, after the universe's rapid expansion, matter should be distributed more or less evenly, with galaxies moving apart as space stretches. On the largest scales, their motion should appear random, dictated by local variations in gravity. But the dark flow suggests otherwise. Galaxy clusters millions of light years apart are drifting in the same direction, at speeds of nearly 1,000 kilometers per second, as though pulled by a hidden force originating outside the observable universe. For scientists accustomed to a self-contained cosmos, this was not just unexpected, it was revolutionary. The first evidence emerged from NASA's Wilkinson Microwave Anisotropy probe, which mapped the faint afterglow of the Big Bang, known as the cosmic microwave background. Embedded in this ancient radiation were subtle distortions caused by galaxy clusters moving through space. And in 2008, researchers announced something shocking. These clusters were not just moving, they were all moving toward the same region of the sky, in the direction of the constellations Centaurus and Hydra. This coherent motion could not be explained by known gravitational structures. The implication was clear. Something beyond the limits of our observable universe was exerting its influence. The very idea of a force beyond the cosmic horizon changes everything. Our observable universe is limited by the speed of light and the age of the cosmos, about 13.8 billion years. Beyond that, we cannot see. Yet dark flow hints that beyond this veil lies something vast, perhaps unimaginably so, that still reaches across the boundary to tug on the galaxies within. What could it be? Some theorists propose it may be the gravitational pull of structures outside our universe, remnants of a larger multiverse. Others suggest it could be evidence of universes colliding, the aftershocks of contact with realities that border our own. In this view, our cosmos is not an isolated bubble, but one among countless others drifting in an endless cosmic sea. The thought is as humbling as it is disorienting. If dark flow is real, then our universe is part of something far bigger, a larger framework where the laws of physics may differ, where entire realms of space-time unfold in ways beyond comprehension. To glimpse the effect of such a structure, even indirectly, is to stand at the threshold of knowledge, peering into a realm we may never truly enter. Yet the evidence remains tantalizingly ambiguous. Some astronomers argue that dark flow is an illusion, the result of statistical noise or limitations in our instruments. Others maintain the pattern is real, supported by independent analyses. The debate is unresolved, but the possibility lingers, unsettling and irresistible. Imagine for a moment that we could see beyond the horizon. What would we find? Perhaps massive structures of unimaginable scale, larger than any galaxy cluster, larger than superclusters, cosmic giants whose gravity shapes not just one universe, but many. Perhaps rivers of matter and energy stretching between universes, currents of reality flowing through dimensions we cannot perceive. Or perhaps the dark flow is not caused by matter at all, but by something stranger, a deformation in the very fabric of space-time, a signal from a deeper layer of existence. The philosophical implications are just as profound as the scientific ones. If our universe is not isolated, then our sense of uniqueness dissolves. We become part of a larger continuum, a single strand in a tapestry that stretches far beyond our sight. The story of the cosmos ceases to be the story of one universe expanding into emptiness and becomes the story of universes interacting, colliding, influencing one another across unseen boundaries. Our Big Bang may not have been the beginning, but simply one event among countless others, echoes of an eternal cycle of creation. Dark flow remains one of the most haunting mysteries in cosmology because it forces us to confront the limits of observation. We cannot point a telescope beyond the edge of the observable universe. We cannot send probes into realms where light has not had time to travel. And yet, through the silent drift of galaxies, we may already be witnessing the fingerprints of the beyond. It is as if the universe is whispering that the story is larger than we can imagine, urging us to recognize that what we see is only a fragment of a far greater whole. Perhaps in time, new instruments will clarify the mystery. Perhaps dark flow will be explained by hidden structures within our own universe, massive concentrations of matter yet to be mapped. Or perhaps the data will confirm what some already suspect. that the cosmos we see is but one among many, and that we are adrift in a current flowing toward realms we may never enter. Until then, dark flow remains a symbol of our deepest ignorance and our greatest hope, that beyond the horizon, the universe is richer, stranger, and more infinite than we have ever dared to dream. In the vast silence of the cosmos, our instruments sometimes capture signals so brief and powerful that they defy every explanation. They are known as fast radio bursts, or FRBs, flashes of radio waves that last for only milliseconds, yet release more energy than our sun produces in days. Imagine listening to the deep static of the universe and suddenly hearing a sharp, blinding note, like the crack of lightning across a stormy sky. These signals come without warning, from places far beyond our galaxy, carrying an intensity that should not be possible from objects so distant. And the most unsettling part is that we have no definitive idea of what causes them. The first FRB was discovered in 2007 by Duncan Lorimer and his student, who stumbled upon the signal while analyzing archived data from a radio telescope in Australia. The burst was so unusual, so powerful, that many initially thought it was an error in the equipment. But soon, more bursts were found, each with the same distinctive signature: an intense flash of radio waves coming from billions of light years away. They appeared randomly, scattered across the sky, like cosmic fireworks leaving no trace behind. From the beginning, the mystery was clear. What in the universe could generate such immense power in such a short span of time? One of the most perplexing features of FRBs is their brevity. A typical burst lasts less than 1,000th of a second. Yet in that instant, it releases more energy than an entire galaxy's worth of stars combined. To put it in perspective, if you had a radio antenna tuned to the right frequency and sensitivity, you could, in theory, detect an FRB on Earth with something no larger than a smartphone, even though the source lies billions of light years away. That fact alone reveals the unimaginable violence of the processes behind these signals. Over time, scientists began to categorize them. Most FRBs are one-time events. They flare once and vanish forever. But then came a breakthrough. In 2016, astronomers identified the first repeating FRB, a source that flashed multiple times over months and years. This changed everything. It meant that at least some FRBs were not cataclysmic explosions, like the collapse of a star into a black hole, but something that could endure and produce bursts repeatedly. Later, more repeaters were found, some even with strange periodic patterns, as if they were pulsing with regularity, like a heartbeat across the void. Theories about their origins span the spectrum from the conventional to the fantastical. Some suggest they come from magnetars, exotic neutron stars with magnetic fields trillions of times stronger than Earth's. When their crusts crack or their magnetic fields shift, they could unleash titanic blasts of energy detectable across the universe. Others propose collisions between neutron stars or black holes consuming matter in violent bursts. Yet none of these explanations fully account for the variety and power of FRBs, nor their sometimes uncanny regularity. And then there is the more speculative possibility, the one that captures our imagination. Could FRBs be artificial? Some scientists have dared to ask whether these bursts could be signals from advanced civilizations, perhaps byproducts of interstellar technologies beyond our understanding. A few have even proposed that FRBs could be beams from alien spacecraft, harnessing immense energy to travel across galaxies, with the bursts being detectable leaks from their engines. While this idea remains controversial, it persists because FRBs are unlike anything else we have ever observed. In 2020, the mystery deepened further when, for the first time, astronomers detected an FRB coming not from billions of light years away, but from within our own Milky Way. The source was traced to a magnetar about 30,000 light-years from Earth. This confirmed that at least some FRBs can indeed come from natural astrophysical phenomena. Yet it did not resolve the enigma. If magnetars can create them, why are many FRBs so much more powerful than the ones we've observed nearby? Why do some repeat predictably while others vanish forever? Why do their signatures differ so dramatically? The search for answers has only intensified. New instruments like the Canadian Hydrogen Intensity Mapping Experiment, CHIME, have detected hundreds of FRBs, revealing patterns that deepen the puzzle. Some bursts appear to come from the edges of galaxies, others from dense star-forming regions. Their distribution seems random, but their physics suggests hidden order. Every detection is both a breakthrough and a reminder of how little we know. For now, FRBs remain one of the most electrifying mysteries of modern astronomy. They are voices in the darkness, shouting across billions of years, carrying with them secrets of processes so extreme that we can barely conceive of them. They might be natural phenomena unlike any we have yet classified. They might be something entirely outside our expectations. What is certain is that they are reminders of the vast unknown still waiting in the cosmos, proof that the universe is far from silent, that even in its deepest darkness, it speaks in flashes of unimaginable power. As we continue to listen, we must ask, are these bursts mere accidents of nature, or are they deliberate signals, messages that we have yet to decode? The answer may one day redefine our understanding of life, intelligence, and our place in the universe. Until then, vast radio bursts remain one of the most haunting invitations the cosmos has ever sent, an unsolved message waiting in the static of infinity. There is a force in the cosmos so immense, so irresistible, that it is pulling entire galaxies toward it. Astronomers call it the Great Attractor, a gravitational anomaly hidden deep within the plane of our own Milky Way, cloaked by dense clouds of stars, dust, and gas. It is not a single star, not a black hole, not even a cluster of galaxies as we understand them. It is something far more enigmatic, a vast region of space whose invisible mass exerts a gravitational tug powerful enough to drag our entire galaxy, along with hundreds of thousands of others, toward it at unimaginable speeds. And the most unsettling part is that we still do not know exactly what it is. The discovery of the Great Attractor came in the 1970s and 80s, when astronomers noticed something strange in the motion of galaxies around us. According to the expansion of the universe, galaxies should be receding from one another, carried away by the flow of cosmic inflation. And yet, measurements revealed that many galaxies, including our own, were not just drifting outward with the expansion, but were moving in a peculiar direction, as if being pulled by an unseen hand. This motion, known as peculiar velocity, pointed toward a region of space in the constellation Centaurus. Somewhere there, behind the thick curtain of the Milky Way's disk, lay the source of this mysterious attraction. At first, scientists wondered if it could simply be a concentration of galaxies, a massive cluster whose gravity was influencing the cosmic flow. But as telescopes probed deeper, what they found was even more perplexing. The region around the Great Attractor is part of a much larger structure called the Laniakea supercluster, a cosmic web of galaxies stretching over 500 million light-years. The Great Attractor itself appears to be a gravitational focal point within this supercluster, drawing everything around it inward. The scale is staggering. Our Milky Way, the Andromeda Galaxy, and countless others are streaming toward this point at a speed of about 600 kilometers per second, over 2 million kilometers per hour. And yet, even at that speed, it will take us billions of years to reach it. What makes the Great Attractor so mysterious is not just its pull, but its invisibility. The region lies in what astronomers call the zone of avoidance, the area of the sky obscured by the dense stars and dust of our own galaxy. Even our most powerful optical telescopes cannot peer through it. Only with radio and X-ray observations have scientists begun to glimpse fragments of what might lie behind the curtain. They have found clusters of galaxies, enormous clouds of hot gas, and vast filaments of dark matter weaving through the region. But none of these observations fully account for the staggering gravitational influence that we observe. Something remains hidden, something massive and unseen. Theories about the nature of the Great Attractor vary. One possibility is that it is simply the combined effect of an enormous number of galaxy clusters concentrated in one region, their collective gravity shaping the motions of galaxies for hundreds of millions of light-years around. Another possibility is that dark matter, an invisible form of mass that makes up most of the universe, plays a central role, creating a gravitational well that pulls galaxies like leaves floating toward a whirlpool. Some even speculate that the Great Attractor may be part of an even larger structure beyond it, such as the Shapley supercluster, one of the most massive concentrations of galaxies ever discovered, lying just beyond the Great Attractor's location. In this view, what we call the Great Attractor may only be the edge of something far more immense. And then there are the more speculative ideas. Some have wondered whether the Great Attractor represents a kind of cosmic sinkhole, perhaps even the gravitational influence of something akin to a black hole on a scale we have never imagined, billions of times larger than any we know. Others suggest it might be a flaw in our understanding of gravity itself, a sign that the laws of physics as we apply them to galaxies and superclusters are incomplete. What if the universe is structured by forces we have not yet discovered, and the Great Attractor is their first clue? For now, the Great Attractor remains tantalizingly out of reach. We know it exists because we can see its effects. Galaxies moving in unison toward it, space itself being distorted by its gravity. Yet its true nature is hidden, veiled by the dense plane of our Milky Way, and perhaps by the limits of our imagination. In many ways, it stands as a symbol of the unknown, an invisible presence that shapes the cosmos around us, pulling even our own galaxy toward a fate we cannot yet define. The most haunting question is not whether the Great Attractor exists, but what it means. If our galaxy is on a journey toward an unseen destination, what lies at the end of that path? Will we eventually discover that we are being pulled into the heart of a colossal supercluster, merging with countless other galaxies in a slow cosmic embrace? Or is the Great Attractor merely one step in a hierarchy of structures, each larger and more powerful than the last, leading to something beyond comprehension? Whatever the answer, the Great Attractor reminds us that even on the largest scales, the universe is not a random scattering of galaxies, but a dynamic, interconnected web guided by forces we are only beginning to understand. In the end, we are passengers on this journey, carried along by an invisible tide, moving toward a mystery that will unfold only in the far future. And perhaps that is the true wonder of the Great Attractor. It is not just a gravitational anomaly, but a mirror of our own ignorance, a reminder that the universe is vast, hidden, and filled with destinations we have yet to imagine. When we look into the night sky, we see galaxies scattered like islands of light across the dark sea of space. We see stars, nebulae, planets, and glowing clusters. But here's the truth that unsettles astronomers the most. Everything we see, every star, every planet, every luminous object, makes up less than 5% of the universe. The rest is invisible. It does not shine, it does not absorb light, and yet it dictates the fate of galaxies and the expansion of the cosmos itself. These unseen forces are known as dark matter and dark energy, and together they are the true rulers of the universe. The story of dark matter began with a puzzle. In the 1930s, Swiss astronomer Fritz Zwicky studied the Coma cluster, a massive collection of galaxies. He realized that the galaxies within it were moving far too quickly to be held together by the visible matter alone. By all logic, they should have flown apart, scattering into the void. Yet they remained bound, as if held by an invisible hand. Zwicky proposed that some unseen mass, what he called dunkle materie, or dark matter, must be providing the extra gravity. At the time, his idea was dismissed as speculation. But decades later, with improved observations, astronomers confirmed the anomaly not just in clusters, but in individual galaxies. Stars at the edges of spiral galaxies, instead of slowing down as predicted, moved just as fast as stars near the center. The only explanation was that galaxies are surrounded by vast halos of invisible matter, outweighing the stars themselves many times over. But what is dark matter? Despite decades of study, the answer remains elusive. It does not emit light or energy that our instruments can detect. It does not interact with ordinary matter in ways we can easily measure. Its presence is inferred only through gravity, bending the paths of stars, galaxies, and even light itself. Some theories suggest that dark matter is made up of exotic particles, unlike anything in the standard model of physics. Candidates include WIMPs, or weakly interacting massive particles, and axions, hypothetical particles that could permeate the cosmos. Others have proposed that perhaps our understanding of gravity itself needs revision, that what we attribute to dark matter is instead a sign that Newton's and Einstein's laws are incomplete at cosmic scales. Yet despite countless experiments in underground laboratories and particle accelerators, dark matter remains undetected. It is there, shaping the universe, but hidden from view. If dark matter is the skeleton of the universe, providing the structure on which galaxies form and grow, then dark energy is its restless spirit, driving everything apart. In the late 1990s, astronomers studying distant supernovae made a discovery that shocked the scientific community. The expansion of the universe, once thought to be slowing down under the pull of gravity, was actually accelerating. Some mysterious force, was pushing galaxies away from each other faster and faster. This force was named dark energy, and its effect is so dominant that it makes up nearly 70% of the cosmos. The nature of dark energy is even more mysterious than that of dark matter. Some theories describe it as a property of space itself, a kind of vacuum energy that pushes outward as space expands. Others suggest it could be the effect of an undiscovered field permeating the universe with repulsive power. Still others consider whether dark energy might vary over time, waxing and waning like a hidden tide that could someday reverse, causing the universe to collapse in a big crunch. For now, the truth is hidden. All we know is that dark energy is real, and it is rewriting our understanding of the cosmos. Together, dark matter and dark energy form a paradoxical balance. Dark matter pulls, holding galaxies together, creating the cosmic web of clusters and filaments that give the universe its structure. Dark energy pushes, driving galaxies apart, stretching space itself toward an uncertain future. One anchors, the other disperses. Their invisible duel is the stage on which all of cosmic history unfolds. Without dark matter, galaxies would never have formed. Without dark energy, the universe would not be accelerating toward its unknown fate. The most humbling part of this mystery is that we, the observers, are made of the smallest fraction of reality. Everything familiar, our bodies, our planet, the stars above, exists in the margins of the universe. We are built from rare matter, illuminated matter, while the true rulers remain unseen. This realization forces us to reconsider our place in the cosmos. Are we insignificant, mere sparks in a universe governed by shadows? Or is our role precisely to seek, to question, to attempt to bring light to what lies hidden? Astronomers continue to map dark matter by tracing the subtle distortions it creates in the light of distant galaxies, a phenomenon known as gravitational lensing. They search for dark energy's fingerprints in the accelerating expansion of space, in the faint afterglow of the Big Bang, in the patterns of galaxies stretched across the heavens. Each discovery brings us closer, yet the ultimate answer remains out of reach. Dark matter and dark energy continue to elude definition, like phantoms guiding the fate of everything we know. Perhaps that is the most profound lesson they offer, that the universe is larger, stranger, and more complex than our current science can capture. Dark matter and dark energy are not just mysteries to be solved. They are reminders of our limitations, invitations to expand our imagination, challenges to every certainty we hold. In them, the cosmos whispers its greatest secret. The visible world is only a fraction of reality, and the true story of the universe remains hidden in the dark. Every era of human history has been shaped by mystery. Once, the edges of our maps were filled with sea monsters and imagined lands. Later, the heavens were thought to be a fixed dome studded with stars. Each discovery erased old certainties, replacing them with deeper questions. Today, we stand at the frontier of an even greater unknown, the future of the cosmos itself. What lies ahead for a universe governed by invisible forces, endless cycles, and laws we barely comprehend? This is not only a scientific question, but a reflection on existence itself. The universe is expanding faster with each passing moment, propelled by the enigma of dark energy. If this acceleration continues indefinitely, we may face what cosmologists call the heat death of the universe. Stars will burn out, galaxies will drift apart, and the cosmos will fade into a cold darkness where energy is too diffuse to sustain life. It is a bleak picture, a universe not ending in fire, but in silence. Yet even in that silence, some wonder if life could adapt, clinging to the faint warmth of dying stars or harnessing exotic physics to endure. The very act of imagining survival is an expression of resilience, echoing the same force that has carried life through extinctions and catastrophes on Earth. But the expansion may not be eternal. Some theories propose that dark energy is not constant, but dynamic. If its strength were to shift, the universe could face a very different fate: the Big Rip. In this scenario, the accelerating expansion eventually overcomes every bond in existence, tearing galaxies, stars, planets, and even atoms apart. It is a vision of ultimate fragmentation, where space itself unravels. Others suggest the opposite possibility, the Big Crunch, where expansion reverses and the universe collapses back into a singularity, perhaps to ignite another cosmic cycle, another Big Bang. In this view, the cosmos is not a straight line toward oblivion, but an eternal heartbeat pulsing through creation and destruction across infinite ages. Amid these vast speculations, another mystery haunts the horizon: the possibility of multiverses. If our universe is just one of many, then the question of its end may matter less than we think. What if each universe is a test case, with different laws of physics, different outcomes, different forms of life? Perhaps our role is not to preserve this universe forever, but to contribute to a greater archive of cosmic variation. In this perspective, continuity does not lie in the survival of one cosmos, but in the proliferation of countless others, each carrying its own lessons into eternity. Closer to home, the future of cosmic mystery is also tied to the fate of humanity. For thousands of years, we have looked at the stars and asked what they mean. Now, for the first time, we possess tools capable of exploring them directly. Telescopes like James Webb reveal atmospheres of exoplanets, tracing molecules that may hint at alien life. Particle colliders probe the building blocks of reality, searching for the fingerprints of dark matter. Quantum computers and artificial intelligence may one day model the universe with a precision we can scarcely imagine. The question is whether we will live long enough and wisely enough to use these tools to uncover answers rather than accelerate our own downfall. There is also a philosophical future to consider. As we probe deeper into the cosmos, we are forced to confront the limits of human perception. We may discover that some truths are forever beyond our grasp, hidden not by distance or complexity, but by the very structure of reality. Perhaps the ultimate mystery is not something to be solved, but something to be lived with, a horizon that always recedes as we approach. If so, then the value of inquiry is not in final answers, but in the endless expansion of perspective it provides. Yet mystery is not only humbling, it is empowering. It reminds us that there is always more to seek, more to imagine, more to learn. Every unanswered question is an invitation to stretch the boundaries of thought, and in a universe where most of reality is hidden, this spirit of curiosity may be our greatest survival trait. Long after our civilizations crumble, long after Earth itself is gone, the legacy of humanity may be defined not by what we conquered, but by what we dared to ask. The future of cosmic mystery is uncertain, but it is also open. The universe has never promised us permanence, only the chance to exist within its vast experiment. Our role is not to control its outcome, but to shape our response to it. Will we look at the unknown with fear or with wonder? Will we resign ourselves to insignificance or embrace the possibility that our curiosity is itself a form of cosmic significance? Perhaps the most profound truth of all is this: the mystery is not a barrier, but a bridge. It connects us to everything beyond ourselves, from the smallest particle to the farthest galaxy. And as long as we keep searching, the story of the universe will not be complete. It will continue to unfold, not just in the stars, but in the questions we dare to ask. We began this journey by asking whether the universe is filled with mysteries we may never fully solve. Along the way, we walked through signals no one can explain, structures that defy physics, alignments written into the stars, and forces so immense they bend reality itself. Each mystery left us with more questions than answers, and perhaps that is the essence of the cosmos, not to hand us certainty, but to challenge us with an endless frontier of the unknown. The story of the universe is not a book with a final page, but a horizon that expands the closer we move toward it. And here we are, at the edge of that horizon, looking back at everything we've uncovered. The inexplicable signals that whisper across the stars remind us that we may not be alone. The dark rivers of matter that sculpt galaxies but remain unseen force us to admit how little of reality we truly understand. The ancient alignments carved into stone, echoing forgotten moons and lost civilizations, show us that our ancestors, too, gazed into the skies searching for meaning. And the futures we envisioned, heat death, collapse, rebirth, or multiverse, push us to confront the possibility that our universe is only one of countless experiments in existence itself. What then is the lesson? It is not that we must solve every riddle or master every equation. It is that we must remain seekers. The cosmos tests us not with answers, but with the persistence of its questions. Every mystery is a mirror, reflecting who we are in the act of searching. Do we give up when confronted with the unknown, or do we lean forward, daring to imagine more? That choice, more than any discovery, defines our place in the great experiment of existence. The responsibility is ours. If we look away, the mysteries remain, but our role in them vanishes. If we choose to confront them, to wrestle with their implications, to imagine what lies beyond the edge of certainty, then we become part of something greater than survival. We become participants in the story of the universe itself. That is the quiet but powerful truth. The universe does not simply unfold around us. It unfolds through us in every question we ask, in every mystery we dare to face. This is why staying until the end matters. This is why every voice that joins this journey strengthens it. Because what we are building here is not just a channel, it is a collective pursuit of wonder, a gathering of minds unwilling to accept the easy answers, a refusal to let the unknown remain silent. When you choose to subscribe, when you choose to share, you are not just supporting a video. You are aligning yourself with a community that believes curiosity is sacred, that questions are powerful, and that the mysteries of the universe are worth chasing together. Think about it. Somewhere out there, perhaps light years away, another civilization may be asking the same questions we are. They may be watching their own stars flicker strangely, building their own monuments to the sky, writing their own stories of collapse and renewal. If the cosmos is filled with countless tests, countless seekers, then maybe what connects us across those impossible distances is not technology or conquest, but curiosity. The drive to know, the hunger to understand, the refusal to stop at what seems obvious. And here, in this small corner of the digital universe, we echo that same drive. So, the call to action is not a cliché. It is an invitation. If you have felt the pull of these mysteries, if you have sensed the weight of these questions pressing against the edges of your mind, then join this journey. Stay with us, subscribe, and share not just because it helps, but because it declares something profound, that you are not content with silence, that you believe in listening to the universe, in reading its riddles, in chasing its secrets no matter how vast the distance. The mysteries may outlast us. The stars may one day fade, but as long as there are those who dare to ask, as long as there are voices willing to wonder, the story is not finished. The cosmos remains alive, not just in its galaxies and stars, but in the questions that echo within us. The experiment continues. The test is not yet complete. The question is whether we will rise to meet it. Will you?